Okay, so for the second half of class today, and like I said, we'll do this pretty much every week where we'll spend first half going through notes, second half doing some skills. So I've taught this groundwater course many times. And the one thing that really seems to prevent a lot of people from doing really well with some of the problems and the calculations that come later in the semester is their inability to handle conversions. There's a lot of conversions we need to do in this class. I know you've all done some of these before. Some of you are really good at this, and this will be a breeze, and I'm not going to bore you with this. I'll show you how I'm going to do this in a minute. But some of you, this is going to take a lot of work. So what we're going to do today is I'm going to give you a quiz. It's not graded. I have an answer sheet up here. You can come check your own work. But starting next week, I'm going to give a quiz every week. Okay? Once you get 9 out of 10, you are done. You don't have to take any more quizzes. And you will get a quarter of your homework points at that point, just by passing that quiz with a 90. Okay? And if you don't pass the quiz with a 90, you get to do it the next week, and the next week, and the next week. And if it takes every week of the semester, then we're going to do it every week of the semester. For those of you that pass early on, you can skip those quizzes and go on to the other work we're going to do, or you can take the quizzes just for fun to, see if you're still doing well at them. But we're just going to keep doing it until everybody gets really comfortable with this, okay? When you do these, I don't care as much about the right answer as you doing it correctly so that you always get the right answer. So you're going to do it my way, okay? In this class, you're going to do conversions my way, no other way. That way I can see if you're progressing, where your problems may lie, and I can at least hopefully give you some assistance and help you learn this. So let's just take an example here, kind of how I want you to do conversions. How many of you have done conversions before? Every single one of you. Okay, good. How many of you feel really confident in your ability to do conversions? Yeah, just not nearly as many, right? So, good. This is something you can all do. So, conversions are based on a really simple mathematical property or two. So if we start with any value, let's just say x, okay? And you multiply x by 1, what do you get? Anything multiplied by 1 is whatever itself is, right? So this 1 right here is the key. This is going to be our, what we call, conversion factor. It's going to equal 1. It's also going to be a fraction. How do we get a fraction to equal 1? Anything over itself, right? X over x equals 1. Okay? The whole idea behind these conversions is we're going to multiply by 1. That 1 is going to be a fraction that also equals 1, where the top is the same as the bottom. But what's going to be different is that there's going to be different units in the numerator and denominator. Let me give you an example. Okay, let's do our first example. Let's say we have 100 centimeters. I want to know how many millimeters that is. So we're starting with 100 centimeters. That's our x right there, okay? We're going to take that 100 centimeters and we're going to multiply it by 1. And what we want to end up with is how many millimeters that is. Okay? So the important part of the equation is right here. It's this 1. The 1 is going to be a fraction, right? And the idea behind the fraction is that you want to cancel out this unit right here and replace it with this unit right here. That's really how simple it is. You just want to multiply it by something and change the unit without changing the value. So let's think about this for a minute. So we have 100 centimeters, right? We want to multiply it by something and end up with millimeters. Okay? This 1 again is going to be a fraction. The fraction is what's going to enable us to get rid of the units. So where in this fraction do we want centimeters? If we want to get rid of them. Bottom or top? Numerator or denominator? We want it on the bottom, right? Centimeters on the bottom. We want to end up with millimeters, right? Millimeters on top. But now we have to know how many millimeters in a centimeter or vice versa, right? I think most of you know this. How many millimeters in a centimeter? Or maybe you don't know this one. Go ahead.
I don't know.
Okay. Anybody know? 10. So there's 10 millimeters in 1 centimeter. 10 millimeters is the same as 1 centimeter. These are the same thing, right? Anything divided by itself is 1. So we're not violating any of our mathematics here. The centimeters cancel out, right? What are we left with? Millimeters, correct? 100 times 10 equals 1,000. That's what I'm looking for, okay? A lot of these will be straightforward. Some of them won't be. Let me give you an example. Is a centimeter the same thing as a cubic centimeter? It's not, right? Centimeter's a length, right? A cubic centimeter is a volume. Length times length times length. So let's say we have 10 centimeters cubed. Okay. I want to know how many millimeters cubed that is. Now, most of you probably don't know the conversions between things that are cubic. Very few people do. But you guys know how many millimeters in a centimeter, right? We just did it. So let's think about this for a minute. Let's say we have 10 cubic centimeters. We want to change it to cubic millimeters, okay? I don't exactly know the conversion for cubic millimeters, but I know the conversion between centimeters and millimeters. We just did it, right? So let's say we put centimeters on the bottom, millimeters on top. What was that conversion before? It's 1 centimeter to 10 millimeters, right? What if I just left it like this? What would I end up with? Yeah, see, I'm only getting rid of one of these, right? So what I have to do when you do things that are areas squared or volumes cubed is you have to carry out these conversions a couple of different times. So this is, that's 1, isn't it? We're good, right? But I can multiply it by 1 again, right? And I still don't change the value. So what I can do again is I can do 10 millimeters over 1 centimeter. And because we have centimeters cubed, I have to do it one more time. 10 millimeters over 1 centimeter. So now what do I get for a unit? Centimeters cubed. Cancel out, cancel out, cancel out, right? Millimeters times millimeters equals millimeters cubed. That's exactly what we want, right? So 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. So we end up with 10,000 millimeters cubed. All right, I gave you a conversion quiz, okay? One thing that you must do this semester is at the very bottom, you have to memorize a few standard conversions that you are going to use throughout your career as a geologist. Guarantee you'll be glad you learned these and don't have to look it up every time. I want everybody to know in here that 640 acres, an acre is an area. 640 acres is the same thing as a square mile. So if you have a square mile, how many of you, everybody's used topo maps, right? You guys remember doing the sections and townships and the quarter sections? A section is a square mile. Every one of those red squares on your topographic map is a square mile. It's also 640 acres. A quarter section is 160 acres. And a quarter of a quarter section, which a lot of times you do when you're locating points on topographic maps, is 40 acres. So a 40-acre parcel is a quarter of a quarter section. 640 acres per square mile. The second one is probably the most important for this class. And what's awesome is that it allows you to go from a mass, a gram, to a volume, either in milliliters or cubic centimeters. Water is such a cool substance. 1 milliliter of water takes up exactly 1 cubic centimeter and weighs exactly 1 gram. Which is kind of neat because what I'll show you is that you can actually weigh water with a yardstick. Because this conversion allows you to go from a measurement, length, width, height, to a weight or mass in grams. I also want you to know 1 kilogram is the same as 2.2 pounds. That allows us to switch between English units and metric units. 2.54 centimeters per inch. And then know your basic metric conversions. Micro is 1/1,000,000th of something. Milli is 1/1000th of something. Centa is 1/100th of something. Deci is 1/10th of something. And kilo is 1,000 somethings. And then English, 12 inches a foot, 5,280 feet in a mile, and a ton is 2,000 pounds. You guys need to know all those. You probably know most of them already. So there might be a couple in here along the way. There is one unit that's really weird that you probably haven't seen before, but we use it all the time when it comes to water, groundwater, surface water, and it's something called the acre foot. Acre times feet. It is one of the most common units that we use in water science. What the hell is an acre foot? Any idea? Can you explain to me what an acre foot is? What is an acre? It's a unit of what?
Area.
It's area, right? Yeah, an acre is an area. A square mile, right, is 640 acres. A square mile is an area, 640 acres in that square mile. Okay, so acre is an area. Foot is a linear, right? if you take an acre, if you take an area and multiply it by a linear measurement, what kind of measurement is that? Think about this. What if I had a centimeter square, okay? That's an area, right? What if I multiplied it by a centimeter? What's my unit? Centimeters cubed, which is a volume. An acre foot is a measurement of a volume of water. 1 acre foot is an acre covered with a foot of water. 12 inches deep. It's a pretty big parcel of water. I don't know where y'all grew up or how big your yard was, but right now I have a ½ acre. It's a pretty fair sized little lot, you know? I hate mowing it. It takes a long time. Acre is twice that big. And then fill it with a foot of water. It's quite a bit of water. So that's an acre foot. It is a volume. We use it a lot, and it makes conversions kind of tricky. So I'm going to give you every week some acre foot conversions to do. They're super useful though, because what we do a lot of times is we talk about rain falling on a big area, okay? Let's say we had 6 inches of rain fall on 640 acres. Let me just write that down. 6 inches falls on 640 acres. Actually, just let me go to the next one here. Okay. We have 6 inches of water times 640 acres. How many acre feet is that? Well, this is where the conversion comes in, right? We have acres here, we have acres on the other side. So we don't really need to change this, okay? But we do need to change this, don't we? We need that to be a foot. So 6 inches times the conversion. What are we going to put on the bottom? We want to get rid of the inches, right? Get rid of the inches. What do we want on top? Feet, right? How many inches in a foot? 12 inches in 1 foot. And then we can keep our acres the same. This cancels out. 6 divided by 12.
So you just have it.
So that ends up E being 6 over 12 feet times 640 acres. 6 over 12 is the same as 1/2. It's a half a foot of water, right? Times 640 acres. What's our answer? 320. What's our unit? Acre feet. So that's how you would do the conversion. If that looks difficult to you, you've never seen anything weird like that, that's why you're in the class. Get to learn. You'll make some mistakes. You'll get better. I do this every time I teach groundwater. The first quiz, I don't know if I've ever had anybody get the first quiz a 90. Usually it takes 5 or 6 for some people. I had one student last time that finally got their 90% the last week. And that's cool. I don't care as long as you get it. You're going to practice till it becomes just second nature to you. So what I want you to do is take the conversion quiz right now. Do your best on it. When you're done, come up, show me your quiz. I just want to take a look, Make sure if you have questions, ask me. And I have an answer key with all the answers written out right here. So you can just sort of take a look at it, see how I did it, see how you did it. If you didn't get it right, see where you made the mistake, talk to me. I'm here. Normally I would walk around, but I don't want to give you COVID, and I don't want you to give me COVID. So stay out there. I'll stay up here. But as soon as you finish, come on up. Once you feel comfortable with it, you can head off for the hills.